Hi, I'm Eric. I'm a developer at Universe Sandbox, and today I'm going to show you a couple of new features we've just added that I think are going to be a lot of fun and also quite educational, particularly with regards to exoplanet detection. So here's a system that we've put in. It's just a little demo fictional system. It's got a couple of massive planets around the sun. They're very close in. And so there are two main methods that are used to detect exoplanets, the radial velocity technique and the transit technique. And we actually have both available here. So I'm going to plot up the radial velocity of the sun. This is computed in real time relative to the camera. And I'm going to go ahead and set the time span here to something a little easier to look out, 15 days. And what you can see is actually that the radial velocity of the sun, here it is. You can see the sinusoids as they go around. And because it's computed relative to the actual camera, when you put it edge on so that the inclination is very low, and you can see that the inclination is listed here, the radial velocity signal is maximized, and this just happens because as the planets orbit the sun, they pull on it gravitationally, which means that the sun sort of moves around in a circle, and in part of that motion, the back and forth motion, is what we call radial velocity. So uh, the fun educational thing about this is when you can sort of adjust the inclinations. So I'm going to here put the inclination very close to face on, about 90 degrees, and you can see that the radial velocity signal basically just flatlines as expected. So this is a really cool way of being able to look at radial velocities, and you can set up all kinds of fictional systems, put planets much further away, etc., etc., and really explore how the physics of this works. We also have a normalized light curve. So this gets to the transit technique, and this is when a planet passes in between the star that we're looking at and the telescopes here on Earth. So I'm going to go ahead and pause the simulation, and I'm going to plot up the normalized light curve, and I'm going to set it up such that Jupiter is about to pass in front of the sun. So I'm going to sort of really make this obvious, and I'm going to go ahead and set this to something a little easier, about 10 hours. And I'm going to slow down time a little bit so we can see this transit happen. So with this technique is when a planet or some other object goes in between the object that we're looking at, it actually blocks part of that light, and you can see this is a dip in the light curve. And so there was the transit of Jupiter. Here comes Saturn, so we'll just go ahead and watch this one as well. And you can see there's going to be another dip, but it's smaller because it blocks a smaller fraction of the light. Right, so the maximum transit depth with less. We also have the Earth and the Moon, and those make very subtle dips in the transit. But there you go. So with the combination of these two techniques, you can actually explore exoplanet systems, and in particular how people here on Earth using telescopes are able to explore and learn about exoplanets. Thanks.